Okay, question F then. So, given that sine 5 theta is 5 sine theta minus 20 sine theta cubed plus 16 sine theta to the 5, well, that should be familiar to, our further math students. You just do that by some demois and then some binomial expansion here and there. Okay, and it says for all real theta, well, of course, it follows that the value of sine 72 is what? Okay, so I suppose if they give you that identity, you've got to sort of use it in some way, right? But then when I first did it, I never actually used the identity. So what I did, let me show you guys my method of going for it, was that first of all, I know that's not 0. Clearly. It's not negative either. Square roots are positive, right? So if you put negative in front, then it's negative. So I'm left between A and D. But then the thing is, I can make a very loose upper bound for D. So I could bound above by, say, 5/8. That works, right? Don't know why it overlapped itself. But this is less than 5/8. The option D is less than 5/8. Okay, because I just got rid of the root 5 essentially. And this is less than square root 3/4. Don't know why it overlapped itself again. But there we go. And what is 3/4? Well, what square root 3/4 rather? This is sine 60. This is sine 60. And we know that sine is an increasing function, right? At least between 0 and 90. So sine 72 is an upper bound for that. Therefore, it must not be equal to sine 72. And we know, therefore, the answer would be A. That's how I thought of it at the start. But I think what they did was that they somehow used theta as 72 here, and then this becomes sine 360, right? And sine 360 is 0, so you solve from there. The quintic becomes becomes a quartic instead, and then it's factorizable or something. But I think my method works better here. But probably if the options were slightly more ambiguous, then my method might not be outright okay. So it depends on the situation.